So, just a quick recap of everything that we've done so far. Simple operational surds. That pretty much includes adding, subtracting, multiplying, dividing, and then you have to actually simplify surds, and then we'll just go through all of that pretty easily. So, first off, what's a surd? It's pretty much an irrational number expressed using the root sign. So, basically, every time you were to simplify a number and you're trying to go as simplest as you can, if your number ends up looking like this and it's like that, like square root of 3, for example, this number is an irrational number. But say, for example, if I end up with square root of 4, we know that the square root of 4, if we were to simplify it, it would just end up being the number 2, which is actually a rational number. Okay. So this is just something that you may or may not know. This is just some general knowledge. If you have forgotten, if you do any base to the power of 1/2, this technically means that it is the square root of that specific base, okay? So if you squared this specific right here, circled in purple there, you can see that we can actually write it like this. And if we use the fourth index law, if you do remember, basically all you're doing is multiplying the powers. As you can see here, I have 1/2 times 2, and you can actually just cross cancel it, being 1 to 1. You end up with just 1 as your answer. So a to the power of 1. Now, obviously, you know that anything to the power of 1 is just the base itself. Hence, this theory where it's like if you were to square any square rooted number, it's just a number by itself. You just end up with the number by itself, okay? So, for example, here, it could be a number, could be a variable, I don't know, whatever that you see in the test. If you see anything like this, where the square root, if you multiply it by itself, because squaring is just a number multiplied by itself, okay, this is the same case as if you were to square a rooted number. So square root of 3 squared, you just end up with square root of 3 times square root of 3, which just equals to the number 3 itself. So right, adding and subtracting surds, okay? So I explained this all earlier, so you don't need to do that. This is the most important thing, okay? You must have the, once you're adding and subtracting surds, you have to make sure they have the same number underneath the root sign. So I've already underlined them. So in my two examples here, I have 2 root 3 plus 3 root 3. Now, the number 3 inside the square root is the like surd in this case. So because they are like surds, you can actually just apply the operations for the numbers in front, which is 2 and 3 highlighted in the purple there. So you just read it out as 2 plus 3, which ends up being 5, and then you have 5 root 3 being your answer. Same case with the second example, 11 root 7 minus 2 root 7. We can see that they are like surds because the number 7 is that like term-ish. So you just go 11 minus 2, which is 9. Okay? So in this slide here, um, if by chance what you get are questions where when you're adding and subtracting and they are no like surds, okay, you must keep them separate, okay? So in my example here, I have square root of 3 plus square root of 5. As you can see here, 3 and 5 are not the exact same. Like, they're not the same. So it's just like algebra. If you were to do something like this, x plus y, you can't combine them together. You can't be xy. That's wrong. That's only the case where it's x times y. Then you can combine them together. But when you're adding and subtracting, you have to rewrite it separately. But if they do have the same like term in algebra, you can combine them together. So 1 plus 1 just equals to 2. So same case here. Now, I'll just go through some examples. It should be quite easy to do. This is like the very easy stuff. So first step is check for the like surd. So I'm going to look at the number underneath the square root sign and see if they're the same. In this case, they are. We have the number 5 here. Now, because we have confirmed that, we can just add the two numbers in front together, 2 plus 6. And at the end, just add in square root of 5 like that. Once you do that, you can combine them together, and this will be your final answer. Now, for this specific case, you need to be very careful. Just like in algebra, if you see the letter or the variable by itself with no number in front, the supposed number that you're supposed to uh, point out is that this number is actually the number 1. Okay? So the number 1. So 1y. This is the same thing with the square root right here. As you can see, we have no number in front of this first square root of 3 here. So what I would like for you all to do is just put in the number 1. Okay? If just to make your life a bit easier, just rewrite the whole thing, but with the 1 included. It now becomes 1 root 3 minus 5 root 3. And then we just carry out the same rules as we did previously. So check for the like surd. Let's just check here. Are they the same number? In this case, yes. Now, because they are the same, we can just apply the operation like normal. So this will just equal to 1 minus 5 and then to the square root of 3. Now, positive 1 minus 5, just if you think about it from a number scale point of view, if that's 0, that's 1. You're going to go backwards 5 times. So 1, 2, 3, 4, 5. Wherever it lands, that's your answer. In this case, it's negative 4. So it's actually negative 4 root 3. Now over here, you can have another look, retry it yourself, but I'll just give you some time to do that in your own time. Now, multiplying surds. This is very important, especially because it leads to simplifying. You're going to need to know this skill if you are going to simplify surds, okay? You need to know how to do that. So this is just a general formula here. So I have some random number inside the square root there, another random number in the square root there. Over here, you just combine them together by algebra, by multiplication pretty much, because every time you see a times b in algebra, we always write it as ab. We just pretty much get rid of the multiplication sign. So for my example here, I have square root of 5 times square root of 3. I'm going to rewrite it as 5 times 3, and we just know 5 times 3 is 15. Please make sure that you know your times tables, okay? Times tables, very important. Times tables. Super. Now, dividing surds. Dividing surds can be similar to multiplying, okay? But it's just got a few different rules. So over here, I have a random number and a random number in A and B. Now, another way of writing this first section here, underlined in purple, is this way here, underlined in dark blue. Okay, so it's just the first, the first one, and in the numerator, and then in the second one, you put that in the denominator. Okay, so once you get to this stage here where it's underlined in blue, you can actually just combine the square root signs together, and then it just becomes a over b, which is the same thing as a divided by b. In simple terms, all you're doing is just dividing the numbers inside the square root. So as you can see in my example, I have square root of 10 divided by square root of 5. I'm just rewriting it. So you can actually skip from here to here if it makes your life a bit easier. And then after that, you just go straight to your answer. 10 divided by 5 is 2. Now over here, I'll just go over it very simply. I have square root of 3 times square root of 10. If I were to go back to my formula right here, as you can see, just based on my example, I'm just multiplying the two numbers together. So over here, I'm just going to do square root of 3 times 10, and 3 times of 10 actually just equals to 30. So you just write square root of 30 and you're done. Same case here, 24, square root of 24 divided by square root of 8. I'm just going to put them all into one fraction, 24 over 8, and put it like inside the square root. After that, you just do your typical number stuff. 24 divided by 8 just ends up being 3. Now, you can try this out yourself. I'll have more a bit later on, but other than that, it's pretty easy. Now, this is where we start getting serious. So, squaring and square root, they're technically opposites of each other. Okay, so you should all know squaring just means multiplying a number by itself. So, if for my example here, I have 5 squared, I'm going to know that is 5 times 5, and 5 times 5 just means 25. Okay, this number here that you get after you square, it's something called a perfect square number. And this is very important for later on. Square rooting is like the opposite, like you're working backwards in this case, okay? So s- you're pretty much finding the original number that multiplies by itself by to get the number inside the square root, okay? So the square root of 25, we're trying to go back to what number was multiplied by itself by. In this case, we know it's just 5, okay? So you need to know how to simplify these kinds of numbers here. So other examples, square root of 16 is 4. Square root of 9 is 3. The reason being is because 4 squared, which is 4 times 4, equals 16. As you can see, you're working backwards, okay? You're trying to find base pretty much, if that's another way of putting it. So 3 squared is 3 times 3, which equals to 9. You're trying to find the base. Simplifying surds the most important part of this whole testing right here. So when you are simplifying surds, okay, what we're doing is we're pretty much trying to split the number into its factors. But the thing is, one of its factors has to be a perfect square number. That is any one of these numbers right here. Okay. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. So when you split the number, one of those numbers has to be them. Okay? Just one of them. Not both, just one. Okay? So if you look at my example here, I have the example square root of 50. Now, some people may be good at the multiplications, some are not. That's perfectly fine. It's just a matter of trial and error. Just do your best, okay? Just go through it slowly. Like, if I want to know what square root or what 50 breaks up into, let me try it out with the number 4. Like, let's just think how many 4s can go into 50. Now, the thing is, when you want to do that kind of thinking, you have to make sure it's a perfect whole number. You can't be having decimals. If you start having decimals or like remainders, then that number doesn't work. So you just move on to the next one, okay? So, I would avoid using 1, okay? Avoid using the number 1 because we know 1 times the number itself. It's already a factor. You need to try and find the highest number possible, okay? So find the highest possible number, like possible square number. Because in some scenarios, you might get a number where you think 4 works, which it definitely does. But what about 16? 16 could also work as well. And I'll show you later on what I mean. But for now, just make sure you're looking for the highest possible square number when you are trying to break it down into its factors. So for the number 50, I have worked out that 25 times 2 actually does make 50. And the thing is, 25 is one of the numbers that we have here in our perfect square number list on the bottom right. So what we're going to do next is we are going to separate the surd and go from here to here. So we've just pretty much just split up the square root and we've just written those numbers separately. The next step is to actually just simplify the surd and clean it up. So we know that the square root of 25 actually just equals to 5 right here. Now, do you know what the square root of 2 is? No. So it's actually going to just stay the same. So this here will stay like that. Okay? Now, once you do that, you want to get rid of the times sign or the multiplication sign and then just put it together. So your final answer will be 5 root 2. So that's about it. I'll just do some examples here. I have square root of 18. I am going to try and find factors such that I have a perfect square number. So I'm going to have 18 here. So I'll just write it down here. 18 can actually be split up into, let's just have a look, 9. Because I know from my 9 times tables that 9 times 2 actually does equal to 18. So I'm going to do this and do this. So put 9 and 2. Now, it is highly important to put the perfect square number in front. Okay? Especially when you're splitting. When you're splitting. So I can actually rewrite square root of 18 to be square root of 9 times 2 like that. This then leads to this. And now I know that the square root of 9 actually equals to 3 because 3 times 3 is just 9. And that's what you're trying to find. Just remember the rules of square rooting. Now I'm left with 3 times square root 2. And if you were to get rid of the multiplication sign, it would look like this, 3 root 2. And that is the square root of 18 done. Okay? Now, let's go with the square root of 72. Now, there are two combinations that you can use. Okay? There is 4 and 18. But remember the rules. We are trying to find the highest possible square number. So let's see if 9 also works for 72. In this case, yes, because we know that 9 times 8 actually equals to 72 as well. So the whole point is to try and find the highest one, okay? High square number combination. And plus, it makes your life a lot easier in the long run. So let's just work it out. So I have square root, I can split this up into square root of 9 times 8. And now I'm going to separate it 9 times 8 like that. Now we know the square root of 9 is just 3. So if we were to write our final answer, we end up with 3 times root 8, which equals to 3 root 8. Now, I would highly recommend for this step that I have circled here, you actually don't need to write this. You can in fact go from this orange point that I've marked with an asterisk to the final answer. You don't need to write unnecessary steps because I can tell. But it is up to you based on how comfortable you feel. Now let's just do square root of 12. We can break that up to either 2 times 6 or 4 times 3. Now the thing is, 2 or 6, they're not a perfect square, like none of them, like 2 and 6, they're not a perfect square number. So what you're going to do is you're going to ignore these numbers. Use the other combination instead, okay? So let's just rewrite this. We're going to use 4 and 3. This equals 2. 4 times 3 inside the square root. The next step is to separate it. And then we know that the square root of 4 actually just equals to 2. So if you really want to, I'll just follow this for now. 2 times root 3. And then if you clean it up, it becomes 2 root 3. Now that is just simplifying surds. The next stage is when you're given addition and subtraction, and then you have to actually simplify the surd as well. So I'm going to go through all of this quickly. Now we have some answers from for like some of these simplifyings already. So I'll just quickly write them down. You can refer to a couple of the slides back to find the answers that I use, but it's very straightforward. So this will be what is it? 3 root 8. Oh, whoops! I made a mistake. So yeah, this is something that's quite common here. So as you can see, for square root of 72, if you look at your final answer, 3 root 8, I'll just make something new. So this will be what? Delete, delete, delete. Oops. Let's just get rid of that. Delete. So let's just go here. So we found out that the square root of 72 just ends up being 3 root 8. But the thing is, if you look here, square root of 8 can actually be broken up further. So if we break up 8 using our perfect square number, whoops, paste, paste. We can split 8 up into 4 and 2. And then just using the same steps, so square root of 8 can be broken up to square root of 4 times 2. Then we can just separate it like this. And the square root of 2 just actually ends up being 2. Hence the square root of 8 equals to this, 2 root 2. Now, as you can see, this now becomes 3 times 2 root 2. So the final step here is to actually just multiply the two numbers on the outside together. So you actually get 6 root 2. So in fact, if we were to refer back here, 9 and 8 is actually not the highest combination possible. It is actually, in fact, 36 and 2. Okay? 72 can be split up into that. And then we can actually double check our answers by taking the number in front of the square root. In this case, it's 6. We're going to square it. So 6 squared is actually equal to 6 times 6, which equals to 36. After that, you just multiply it with the number inside the square root. In this case, we have the number 2. So if we just do quick multiplication, 6 times 2 is 12, put the 2 in there, put the remaining 1 on top of the 3, then we're left with 3 times 2, which is 6, plus 1 with the remainder ends up being 72. So 6 root 2 is actually our final answer. Okay? So referring back to this, we'll just write down our answers. 6 root 2 minus 5 root 2. So Let's just check if there's like surds like previously. So 2 and 2, they both work. So now we're just going to add or subtract the 6 and the 5. Okay. So this will now become 6 minus 5 root 2, which equals to 1 root 2. Now the thing is, we don't actually write the number 1 here. So you can in fact just write root 2 by itself. Now let's just go through the rest here. So the square root of 12, 4 and 3. Okay. Put the square root on top of them. And then this just ends up being 2 root 3. Now 27, you can break it down into 9 and 3. So this now becomes square root of 9 times square root of 3. Now square root of 9 is just 3, and then square root of 3 stays the same. So now you can actually just rewrite this. It will now become 2 root 3 plus 3 root 3. Check if the like surds are there. They are. So you can just add the operations for the numbers in front of them. 2 plus 3 is 5, okay? Now, over here is when it sort of gets tricky, especially with this number here, 2 root 18. Now, just imagine that this is similar to like 2 times x. And what you're going to do is multiply your answer by 2, especially once you simplified square root of 18 afterwards. And I'll walk you through this. So let's just break up 18 into what we know, 9 and 2. Okay, we do that, separate, times, ends up being 3 root 2 here. Now this just is 5 root 2 from what we know. Now, this is what the tricky part here. So I am actually going to replace this 3 root 2 that I found after simplifying into where square root of 18 is in my original question. So this will now become 2 bracket 3 root 2 minus 5 root 2. Now you may be wondering, oh, what do I do after here? It's actually quite simple. Just remember what I said earlier. It's like 2 times x. So what you are actually going to do, so if you just remember from our multiplying surds rule, when you multiply the surds, you only multiply the inside numbers if you are actually multiplying the inside numbers together like this separately. But in this case, we actually have outside numbers instead. So we are actually just going to do 2 times 3 root 2 minus 5 root 2. This ends up being 6 root 2 minus 5 root 2, which is the same as our question 1 up here. Same answer as our question 1, which is root 2. Okay. Now, you need to get comfortable with doing this. This slide, very important. Okay. Simplify the surds first as much as possible, and then you just add and subtract by collecting the like surds together. So I hope this has been helpful. Please study hard over the weekend. For those who did their test today or on Friday, especially because like most of the some people in the class were gone for sport. Okay, I'm going to give you around 20 minutes extra just to get this done. Please study hard over the weekend. Try your best. If you have any help, please send a message on Zuno. Thank you.